Okay, can I ask you to, if you're not wearing a mask, can you sit socially distanced, please? If you decide not to wear a mask, if you decide to wear a mask, you can sit where you want. There are all spaces up here as well available if you're wearing a mask.
What, facing the wrong way?
Facing
no, preferable if you're facing the right way, because we're here. If you can see what we're doing, that's a great advantage for you.
Why does that not work? Why does that not work?
We'll sort that out between now and next week. I mean, normally there are screens at the back of the room, so if you're facing the other way, it's okay, but they're not working this week. Okay, there might be another problem here. Look. Share.
Yeah. And share camera. Cancel that share camera. Now try that one. Hold this one. Is it not? There it is.
Yeah, it's the wrong way around.
Put it up.
Wait.
Come up the right way.
Come up the right way.
Yeah. I'll go find a technician to sort this out. You want to start?
Yeah, I'll start the
session.
Yeah, why don't you introduce yourself, since this is here.
Okay.
Hello.
Hello, everybody.
We've got
microphone. Yeah. You want to use the pickup mic?
No.
Okay.
You look like a karaoke singer.
I am a karaoke singer. Okay. Good morning, everybody. Econometric methods. I'm the convener of the course. Peter teaches the lectures. I do the workshops. My details are here. They're my office hours are Mondays 3 to 5, and between 3 and 4 you can turn up. And after that, 4 to 5, if you want a longer appointment, for example, if anything you find anything today in these workshops you don't understand and you want to go through it one-on-one, you can make an appointment for the second hour, my office hour, and we'll go through it one-on-one. So you know, if you want a longer session, then send me an email. Okay, these are my details. My email address and my room number. It's in the registry, 3rd floor. Come out the lift, turn left. Second door you come to is my office. Okay. I'm going to try and get someone to look at the screens at the back. For some reason they should be showing, and if the room fills up, we'll need them to be working.
Okay, and how many people in the room are econometric methods?
Good.
About half the people. And how many are financial econometrics? Oh, only 1? 2? Not many. Okay, and how many banking econometrics? A few. And how many MSc Health Economics? We've got a few MSc Health Economics. Welcome. Welcome to ECO, School of Economics. All right, well, it's good to see you all here. It's good to see about the same number of people online as well. Can you hear what I'm saying? It's the first time I've done it in a lab. Yes, you can. Okay, that's brilliant. You're all saying yes. Thank you. Right, what are we doing today? Well, this is a very introductory workshop, and I think part of the reason for this week's workshop is just to sort out all the problems that we're experiencing with the lab. For example, the problem that Joel just mentioned, the screens at the back of the room. We'll try to sort out all the problems between now and next week, but we have an exercise to go through. It's this exercise which is in the handout. Now, does anyone need a handout? I gave these out in the lecture earlier in the week. Does anyone need one? Okay. This is the handout that I gave out on Tuesday. I think most of you were at the lecture on Tuesday. LG4. LG4. LG lecture. Oh, no, sorry. Oh no, I haven't recorded it. I will do. I'll put a recording on over the weekend. I'm sorry, I'll leave that and it will get a. Actually, see, I'll talk about that. Who else needs to hang out? Anyone else? Okay, now I sent an email yesterday, or I sent an announcement yesterday to all of you, and that announcement, can I have your attention, please? I gave you an announcement yesterday, and I told you that every event that will be online will be accessible through the module Economics Dissertation. Okay? Now, why is that? It's because you're all in different modules, right? So the only way we can deliver a module online to all of you is by doing it through a module that you're all enrolled on. So that's why, I'm going to take this off. That's why we are delivering all the online events through the Economics Dissertation module. So for example, at 9 o'clock on Monday morning, there's an online lecture, and please access it using Economics Dissertation. If you don't have, do you have access to Economics Dissertation, Health Economics? That's good. Okay, if you don't have access, just let me know. And yes, earlier in the week there was a lecture. I gave a lecture earlier in the week. The handout that I gave in the lecture on Tuesday, there were two lectures on Tuesday, and I gave you this handout, which contains information about myself and a list of the modules you're doing, and it contained a module outline, lecture notes for week 1, workshops for weeks 1 and 2, a formula sheet and a T-distribution. And on the next page there is a module outline which gives a list of lecture topics, a list of workshops and information about the assessment. And then I started the lecture and I went through the lecture. I will do it again. I will put a roughly 1 hour recording on the Economics Dissertation Blackboard site, which essentially does the same thing as I did on Tuesday, but you would benefit from reading through the lecture notes as well. And the lecture notes, there are a few pages of lecture notes, which I didn't get to the end of on Tuesday, but I will continue with in the lecture on Monday morning. And then we have workshop 1 in the handout as well, and we have workshop 2. Workshop 2 is the simple regression model. This is the workshop that we will be doing this time next week. As you see at the top of the page, this question should be answered without using a computer package. In other words, using a calculator. You're allowed to use a hand calculator. So just do as well as you can. Bring your answer to the workshop this time next week. Okay, you don't need to photograph this because you've got it in front of you. It's in the handout that you all have. So this is the problem for next week. Good luck with it. Actually, it's quite easy because the answer to this one is, a lot of the answer is in the lecture notes because it's the example I'm using in the lectures to explain simple regression. So you'll find a lot of the answer in the lecture notes. But do your best with it. And then when we're here this time next week, we will do the same question in Stata, which is the computer package that we're using, and we will be interested to see whether we get the same answers in Stata as we get when we work it out using the formulae with a hand calculator. So please do that between now and next week. Just do your best with it. Okay, workshop 1, Introduction to Stata. Now, can you all get into Stata? I think most of you have been on the pre-sessional course. Is that right? And if you're on the pre-sessional course, you were taught how to access Stata. You were also taught, you were given information on how to install Stata on your own computer. And there's a document explaining how you do that on your Blackboard site. Is there any problem accessing Stata? Obviously, when you're in the lab, Stata is there. You just have to open it up. A minute. Share screen. Well, this is Stata. Can the people, you can all see this, the people in this room, I'll ask again, can the people who are watching online see Stata on my computer? I can't see. I can't see your answers. Can someone say yes or no?
You did well. That's because you've got you're sharing the screen. You have to stop sharing.
Really?
Yeah.
Okay.
It's bonkers. The system's just rubbish. So you cancel sharing.
Oh. Don't go.
What?
Let's just see. I just want to see the answers.
Yes, everybody can. Well, one person said.
Everyone, yes. What does that mean?
That means who you transmitted to. When you put something in here, then it comes up.
Okay, tell me again. Could you see Stata 1 minute ago? Okay, great. Thanks a lot. Now I'll share screen again. Share entire screen.
Oh, you'll get everything then. You get all of this stuff.
I know, that's the only way.
Okay.
Okay, so this is Stata. Now Stata consists of 4 windows. There's the command window in which you type commands. Now if you put a star at the beginning of a command, then it's a comment line. So a star at the beginning of a command, just a star at the beginning of a command just means Stata ignore this command. Now I'm going to change the font size. You don't have to change the font size. I'm going to change it so that you can see clearly what I'm doing. And I'm going to change this one as well. You see, if I type hello and I forget to put a star, then I get an error message because it's not a valid command. Anyway, there's the command window, which is here, in which we type commands, and then the output from the command appears in the output window, which is here. This is another important window, which is the history window. And the history window contains all the commands that we've previously used. That's very useful because often we're typing commands that are very similar to commands we've previously used. So all we need to do is click on a command that we previously used, change it if we need to, and run it, and just press enter to run it again. Now you might be wondering why we're typing commands. in the year 2021? Well, you can do it the modern way, which is using drop-down menus. All the things that we're going to be doing, you could do using the drop-down menus by selecting things here and then selecting things from Windows. But you will find that it's probably just as easy to type the commands. That's something we'll be demonstrating to you. In the next week or so, you'll be given a document containing all the stata commands that you will need over the whole year, including for your dissertation. Unless you do a very exotic dissertation topic, you'll find that all the commands you ever need will be on the stata command sheet. We're just finalizing it. We're adding a few new commands to it. That will appear on the Blackboard site in the next week. We're not going to need many different commands today. Okay. Oh, and that's the command window, the output window, the history window, and over here we have the variables window. The variables window contains the data that's currently in memory, a list of the variables that are currently in memory. Now, there's nothing in memory at the moment. Let's see. If you go to your Blackboard site of the module you're taking, and in learning resources, the reason why I need to log in again is because I'm in dissertation. I need to log into the other site to get the data set. Oh, look, I'll just tell you what to do. If you go to the learning resources and find the name of the data file, exp94, and click on it, tell me what happens. I'm going to read it a different way. In the Blackboard site, on the left-hand side, there will be a folder, Learning Resources. Isn't there? Learning Resources? Yes. Click on Learning Resources, and you get a list of the files that are available. One of them is data sets.
Handouts. Download it now, and if you click here, show a folder, telling you where it is, so you can locate it. Now your personal file stuff, that's your so it's in personal file store data download. That's quite clear. Sure. Oh no, you open it, it won't open anywhere else. Okay? Don't try and open this file directly, it can only open its data. It's a PDA file, which means it can only be opened its data.
Now, look, please don't worry about the delay here, because this always happens in the first session of the year, because we are, you know, things have changed and we're just finding out the best way of doing things. So please don't worry about the delay. How do I get onto another Blackboard site? I want to stay on this one, but I need to get onto another one as well.
Yeah, you need to open a browser. Well, Chrome, I suppose, another Chrome.
Okay, I'm already there.
Right, and just log in.
Wow.
UA staff and students. Oh, yeah. Yeah. Come down. There you go.
Well done, thanks. Okay, so what I'm telling you to do is to go onto your Blackboard site, which might be econometric methods or banking econometrics or financial econometrics. Okay, and here we have learning materials, and here we have data sets. So what happens if we click on this? All right, error. So what do we do instead? Why don't we try right mouse, right click, save link as, and then where do we save it to? Save it onto somewhere, onto the computer somewhere, your own file space or just the default folder. Then go back into Stata and go File, Open. Save link as. Downloads. Go into Stata, open, downloads. Okay, and then find where you've saved it to. I've saved it a few times. And then click on it, open. Oh, and that works. Okay, I'm pleased it works. What I've just done is I clicked on the, in Blackboard, I clicked on the file name. I selected Save Link As. I've saved it to a location on the computer. Then from Stata, I've gone File Open. File Open is that this one here, this button here. And then I've selected the file that I want to open. And you can see that the data's been opened because we have a list of the variables here in the variables window. Okay, what's happening?
He needs to shut the monitor down for a second while he refires.
Just for a second.
Yeah.
Okay, go on.
Stream will still carry on.
So they can still hear us and see what's on our screen.
Yeah.
Okay. So it's just.
So we can carry on.
Yeah.
All right. Right. Let's. Have most of us succeeded in reading the data?
Everybody I've looked at has.
If you haven't succeeded in reading the data, it doesn't really matter. Just watch what we do.
Has anyone got any problems still with loading the data? Most of you I've seen have. Okay, I'll just come around. Bear with me a second.
Okay, how many households are in the sample? Let's just get on with the exercise and see what happens. If you type the command list, I would do it and you would see it here. Well, I'll do it so that the online people can see me. Oh, list, lowercase. Oh dear. L-I-S-T, list. If you type the command list, then that's a nice way of just looking at the data that's in memory, looking at the variables. It's given us all the rows of the data. And there are 4 variables. I think I'll wait till I've got this back again, and then I'll get everyone's attention and we'll carry on. So how many households are in the sample? Ah, 500. Yes, thanks for that. The online people have answered the question. And if you type the command list, okay, right. When we type the command list, we get a table with all of the data in it. Now there are 4 variables here: income, adults, kids. This is a sample of 500 households, and the variables on the information that's available on each household is income in thousands of pounds, annual income in thousands of pounds, total expenditure in 1994 in thousands of pounds. So this is an old data set. It's almost 30 years old, so that's why the numbers are quite small. Okay, so don't worry about these households. We've got the number of adults in the household and the number of children in the household. And so, for example, the first household in the sample, household number 1, their income is 37,700. Their expenditure is 17,000. They have 1 adult and 0 children. All right. So that's what this data set is. What is, describe the 100th household in the sample. Describe the 100th household. If you go list in 100, it came up and then it disappeared.
It's on your screen, isn't it? Bloody text message just left.
Came up and then it disappeared.
Okay, so you need to work on the Blackboard site that you're currently broadcasting from.
Doesn't make any difference, does it?
Yeah, because you need to tell what you're sharing.
I'm not sharing. We're not sharing to there. We're sharing to. I've got to stop sharing.
Stop sharing whatever you're sharing,
Okay.
blank screen, and then go back to sharing.
Sharing what?
I would go for Windows, click here, say share.
Well, the people online can see what I'm doing.
I'm not sure why that stopped. Oh, because you haven't put on PC on there.
Oh yeah, I'm sorry. Sorry for the confusion. If you type the command list in 100, then that gives you just the 100th row of the data set. List in 100, that tells us that the 100 household number 100 has income 16,800, expenditure 11,500, adults, number of adults 1, number of children 2. Okay, any questions so far? The next question is find descriptive statistics for each variable. Descriptive statistics being mean, standard deviation, minimum, maximum, and so on. The command for obtaining descriptive statistics is summarize or just sum. Now, little problem here. My font's too big. Make it a bit smaller. No. So I'll make it 12. Summarize. Okay, that's better. If you just type the command summarize, if you type summarize sum, you don't need the whole word. You just need the first few letters of a command. If you type sum and then a list of the variables, you get summary statistics for those variables. If you just type sum, you get descriptive statistics for all variables. And we can see that we have 500 observations, and the mean income is 32,000, the mean expenditure is 23,000, the mean number of adults is 1.98, and the mean number of children is 2.01. And then we have the standard deviation as well. Remember, standard deviation is a measure of the dispersion of the distribution of income. If everyone had the same income, standard deviation for income would be 0. That's what standard deviation means, dispersion. And then we have the lowest and the highest income in the sample, the lowest and highest expenditure. The lowest number of adults is 1. Every household has at least 1 adult, not surprisingly. The lowest number of children is 0, and the highest number of children is 7. Okay, so that's what the data looks like. The next question, how many households have 1 adult and 3 children? Well, and I showed you the list command earlier. There's another way of looking at the data, which is data editor browse. So if you go to the top, data editor browse, another way of looking at the data. We've got the number of adults and the number of children, and we're being asked the question, how many of these 500 adults have 1 adult and 3 children? There's 1. There's another. In row 6 and row 10. So that's what we're being asked. How many households had 1 adult and 3 children? Well, you don't want to go through the list, go through the list of data and count. You want a quicker way of doing that. And the way that you do it is the table command. Table. Table, adults, kids. There. This gives a table, or it's sometimes called a tabulation, of the number of adults and the number of children. And down the side we have the number of adults. Along the top we have the number of children, and in the middle we have the number of households with that combination of adults and children. So what's the answer to the question, how many households have 1 adult and 3 children? 38. Have we all got the same answer? It's this number here. 1 adult, 3 children, 38 households. Any questions? Obtain a histogram. This is part E of the question. Obtain a histogram of household expenditure. Describe the distribution of expenditure. Okay, histogram, H-I-S-T, and then the name of the variable. Now, you could type the name of the variable, or you can select it from here. If you select it from here, you won't get the name wrong. So I'm double clicking there. When I double click there, the variable name appears. I'm going to increase the font of this. So the history window is really important because it shows all the commands that you've already used. I'm going to increase the font size there. Okay, so now you can see better the contents of the history window. The command that I've just used is hist space histogram of expenditure. Now, a histogram has appeared on the screen, and the people in the lab can see the histogram on the screen. Another question I have to ask the online people is, can you see the histogram? Because the histogram's in a different window.
They can't.
Sorry?
They can't.
They can't see it. Okay. Sorry, but how do you know that? Okay, thanks. You can see their answers.
Yeah, they can see it.
All right, the people online can't see the histogram. Okay, and what I'm going to do here,
They can see it.
let's just make sure. Can you see?
You see where it says no there?
Yeah.
That would be able to see that comment. So there's two recordings and they can see both.
Someone said if we click on your photo, not screen, then we can see it. Okay, look, I'm not sure what the answer to the question. I mean, I don't know what's going on here. Okay, if you
Click on the icon. They click on the icon here at the bottom of their screen, what they're seeing, which is a picture of you.
Yeah.
Then they'll get to see your screen, what you're showing.
Oh, really? Okay, for the benefit of online people, if you click on my picture, then you will get,
What you're displaying.
it'll be like I'm sharing the whole screen.
Yeah.
Okay,
See if that helps.
anyway, look, this isn't too important. The histogram is here. What the main feature of the histogram is that it's reasonably symmetric, this distribution, but it's not what we call a unimodal distribution. Okay, there isn't one mode, there are several modes. Okay, look, there's a mode there, there's a mode here, there's a mode here, there's a mode here, there's a mode here. So it's what we call a multimodal distribution. And remember what this is. This is total expenditure over the year. It's the amount of money that the household has spent on goods and services. Why is it multimodal? What's the difference between households here and here? And what's the difference between these households? Is that obvious? Why is there a cluster of households who are spending this amount and another cluster spending this amount? What's the reason for that? What's the difference between the households? Number of people. What about that? It's more likely to be number of people. There's an accumulation of households here, and they probably have one person, or maybe two people in them. 2 people, 3 people, 4 people, 5 people, and so on. So it's the reason for the multimodality of the distribution is because of the size of the household. We're going to come back to that in a minute. Part F, what is the mean expenditure for households with 1 adult and 3 children? Okay, a minute ago we did this tabulation. A minute ago, we did table adults, kids, and we got the number of households with 1 adult and 3 children. If you go table adults, kids, comma, stat, mean, exp, then you get what you want. There's the command that I've just used. Now, the thing about starter commands is that there are two parts to a starter command. There's the main part of the command, which in this case is table adults kids, and then there is a comma, and after the comma you have a list of options. And the options are the things that sort of fine-tune the command to give you exactly what you want. In this case, we don't just want a table of adults and kids. We want in the table, we want the contents of the table to be the mean of expenditure. Oh, and by the way, I'm going to give you a piece of paper physically and online, which gives you all these commands. So you can work through this in your own time if you want to. All right, so what we've got here is a table containing mean expenditure for households with this number of adults and this number of children. So the answer to the question is, what's the mean? I mean, earlier we saw that there are 38 households with 1 adult and 3 children. And for those 38 households, the mean expenditure is 21,750. It's that number there. So obviously that's the way you find the mean for a particular group of households, using the table command with the option stat. Okay, let's move on. What proportion of households spend more than they earn? Now let's look at the data again. I'm going to go to data editor browse. If you just want to look at the data, nice way of doing it is data editor browse. That's this button at the top. Okay, data editor browse. Click on that, you see the data. Now the question we're being asked about here is about income and expenditure. Does a household spend more money than it earns? No, 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 no. Yes, household number 7 spends more than it earns. Expenditure is higher than income. No, and so on. There aren't many. Where's the next one? Wow, there aren't many at all. Okay, how do we find these households? First of all, you don't want to be, again, you don't want to be counting. There's a quick way of doing everything. How would we do this? The way that I would do it is this. We generate a new variable. Generate what should we call it? Overspend. Okay, you can call it whatever you want. Gen is for generating a new variable. Gen overspend equals, now I'm going to go expenditure greater than income. There's the command. If you didn't see what I did, it's there in the history window. And by the way, when the technician came into the room, the problem that he solved was that he made the screen appear at the back of the room as well. I don't think anyone's facing that way, but if you face, if you're at that end of the room, you can't see what I'm doing. Might be better to look at that screen at the back of the room. All right, what I've just done is I've generated a new variable, and this variable is a binary variable. Overspend, it's a binary variable, and it takes the value 1 if the statement after the equal sign is true. Right, this is basic programming. Generate new variable name equals variable greater than variable. What we're doing is creating a variable which is 1 if this statement is true and 0 if this statement is not true. And that's exactly what we want. If I go, let's look in browser again. look in browser again. The new variable that I've just created is in this final column. And sure enough, for household number 7, it's 1. And it's 1 for household 21 and household 28. It's 0 for other households. So this is the variable that tells us if the household is overspending, spending more money than it earns. And the question asks, what proportion of households spend more than they earn? All we have to do here is tabulate the new variable, overspend. If you tabulate, and now this is a little bit confusing. There are 2 commands in Stata that are very similar to each other, table and tabulate. This one is actually tabulate. Let's see. Yes, tabulate overspend gives what I got when I used tab overspend. What about table overspend? What does that give us? Okay, table overspend doesn't give us, it gives us similar information, but not as much. So tabulate is obviously the command we need here. Tabulate, or tab for short, because tab gives us the number of households who spend more than they earn, which is 64 out of 500. You see, 64 do, 436 don't. And it also gives us the percentage, which is exactly what we're being asked for. What proportion of households spend more than they earn? Answer, 12.8%. Any questions? Okay, the next question is plot expenditure against income. Put expenditure on the Y and income on the X. The command for plotting one variable against another is scatter. Scatter expenditure. Now remember, I told you this in the lecture, scatter X income. The first variable that appears in this command is the one that is put on the Y axis. All right, now I'm sharing my screen so the people who are online will be able to see the plot. It's quite important that everyone can see this plot. What this shows is a plot of total expenditure in thousands of pounds against income in thousands of pounds. Now this plot looks a bit too good to be true. Well, actually it is too good to be true. It's simulated data, it's not real data. Okay, it's pretend data. Don't worry about that. A lot of the data sets that I give you are simulated data, but some of the data sets that I give you are real data, particularly towards the end. For example, if you're doing financial econometrics, financial data sets will all be real data. But you know, pretend data is just as good. Pretend data is sometimes better because it can have all the features that we're looking for. Now, what do we see about the relationship between income and expenditure? As income rises, expenditure rises. The more that the household earns, the more they spend on goods and services. And that's very clear. We've got a positive relationship between the 2 variables. And is it a straight line? Is it linear? What do people think? Who thinks it's linear? There's probably a slight hint that the slope is falling as we move from left to right, but it's roughly linear. It would be not a bad assumption to say there's a linear relationship between these 2 variables. Straight line. Okay, let's move on. Create a new variable, size, as the number of adults plus the number of children. generate again. Generate size equals adults plus kids. Number of adults plus number of children is the household size. That is the number of people in the household. Again, if you use the command list, that's another way of looking at the data in the data set on the screen rather than in a different window. So notice I've just typed the command list. I get a list of the data set as it currently is. Notice that over here we have the new variables that I've created. Over here in the variables window, we've got the new variables that I've created. And with the list command, we can see what the household size variable is. Household size is the sum of adults and kids, sum of those two variables, number of people in the household. What happens to expenditure as household size increases? Well, again, this is another plot. Let's do a scatter plot. Scatter expenditure against size. Now what we have is, on the x-axis we have household size. Now notice there are no households with 0 people. The lowest number of people is 1. So we've got single person households, 2 person, 3 person, 4 person. Now it looks like there's a positive relationship again. It looks like as household size increases, expenditure increases. So the more people there are in the household, the more money is being spent on goods and services. However, is this a straight line? No. Who thinks it's not a straight line? No. What is it? Now, obviously, we're going to be doing regression analysis all the way through these modules. Regression analysis is essentially fitting a line through a data set. But I think you can see that it would be inappropriate to try to fit a straight line through this data, because what I'm trying to tell you is, yes, it does increase, but it seems to level off. As household size becomes very large, expenditure stops rising. Now you can see that if you use a command which I will use a few times in lectures and in various places, this command here, LOS, very useful when you come to do your dissertation as well, and you're just looking at data. You're trying to find what the relationship is between variables. Expenditure size. So instead of scatter, the last command was scatter x size. This command is the same, but it's LOS x size. This gives a scatter plot as well, but it also gives this curve. It's not a straight line, it's a curve. It's what we call a non-parametric regression. It's a curve through the data. Now, it seems to rise and then level off and then rise again. Well, you can ignore this bit. This bit doesn't matter because there are only a very small number of households here. So we don't take this part of the curve too seriously. Ignore this part and you've got something which looks not linear but concave. Concave. That is, the slope is high and then smaller and then smaller, and the slope keeps falling as we move from left to right. Why is that? Well, we'll answer that question in a minute. That was part I. Part J of the exercise is create a variable for expenditure per household member. Call this EPHM, expenditure per household member. This is expenditure divided by household size. Plot this variable against household size. Okay, generate expenditure per household member equals, this is expenditure divided by size. If you want to give a variable a label, this is something that you'll be doing sometimes. you type this command, variable label, EPHM. Now, EPHM is a name. Variable names are things like X, Y, Z, EPHM, right? Labels give you information on what the variable is. I'll type whatever you want here, but I'm typing expenditure per household member. Oh, sorry, I got the command wrong there. Now notice if you get something in red, if you ever get something in red, it means you've typed the command wrong. So look and see what you've done. Redo the command. I just made an error because I got the two words the wrong way round. The command is label variable name, and then in double quotes you have the label. Now that's useful. Notice that now in the variables window I have the name and I have the label as well. And when I do a graph involving this variable, on the axis it will show the label, not the variable, not the variable name. The label is always more useful because it's more informative about what the variable actually is. So we're on to the last part of the question. We've generated this new variable, which is expenditure per household member. Plot this variable against household size. Scatter. Well, let's do a low S again. No, sorry, let's just scatter. I don't want to confuse you too much. Scatter expenditure per household member against size. Now, what do we get here? This is the command that I've just used, scatter. Now, it's very tempting to draw a curve through this scatter as well. So if you want to use the command low S instead of scatter, then you get the scatter plot with the smooth curve through it. And obviously, the smooth curve and the scatter itself tell us that there's a very clear relationship between the number of people in the household, which is household size, number of people, and expenditure per household member, expenditure per head, expenditure per person, and that relationship is clearly negative. The more people that there are in the household, the lower the expenditure per head. All right? So this is the most interesting thing about this exercise. And this is economics. We're talking about economics here. I'll just get a piece of paper. Here you go. It's all right. That over there. How do I get the visualizer?
The visualizer, you have to change it here.
Oh yeah, of course. What would I do without you?
Probably a lot better.
Okay. What we've got here is expenditure per household member, and we've got household size. That is the number of people in the household. Number of people in the household goes 1, 2, 3, 4, 5, 6, 7, 8. Expenditure per household member is high for one person households. If you live alone, you spend a lot on yourself. If you live with one other person, you spend less per person. And the more people there are in the household, the lower expenditure per head, per household member is. What are the reasons for that? There are several reasons. There are at least 6 reasons for that. Why is there a negative relationship here? Why is it that when you have more people in the household, you spend less money per person on goods and services?
Total income doesn't increase
one person earns £20,000, if there'll be 2 people in the house, does that mean that they're going to earn £40,000? Usually not, it's going to be less than. It's not going to, if you increase the number of people in the household, it's not going to.
You've got it, yeah. If you increase the number of people in the household, it's probably because the number of children is increasing and the number of adults is staying the same. In fact, you could say that if there are more children in the household, the number of adults who are working is probably likely to fall. More children to look after. So let's just say total income is fixed. Total income of the adults in the household is fixed. When you increase the number of children, there's less income to go round. So more people, less money to spend. Okay, that's good reason. Another reason? I said there are at least 5 or 6. I'm trying to remember them myself. Let's see. Okay. Online, someone said income stays the same if other people are children. That's the point that's been made. Do we have
So the other one.
how do I share that? I've got .cam here.
Cam up and then
Where is it?
go back to where you're broadcasting from, and then click on this over here.
I'm sharing the whole screen.
Yeah, click on this.
Yeah.
One of these share cam. That one maybe, or that one.
Full vision.
Yeah, that's the one. Share cam. There you go. The other economies of scale. You don't buy in bulk, and you break the bulk, right?
Yeah. I might have to ask you again. Right, we've got another. I'm just looking online for the people online who are making suggestions. Many items can be shared between household members. Well, that's true, but more so for particular types of item. Think about the class of items that we call consumer durables. Consumer durables. For example, washing machine. How many washing machines does a household have? 1. However many people there are in the household, there's 1 washing machine. So clearly expenditure per head on washing machines falls as household size rises. Expenditure on cars is the same. Households have 1 car, they might have 2, but they don't have a car for each household member. So consumer durables, it's obvious. What about things that are not consumer durables? Food. Why is expenditure on food per head lower when there are more people? Economies of scale.
Food costs are scalable. Food costs are scalable, as in the more you buy.
Buying in bulk. Yes. When you buy a large quantity of an item in a supermarket, you spend less per unit than if you buy a small amount of the item.
Can you see it? To make it big. So small people don't consume as much as big people.
Okay. You should know. I've just had a suggestion from my colleague. Small people do not consume as much as large people. Okay, so children don't consume as much, right? Children consume less. Okay, bulk buying is cost per unit bought is lower. What about economies of scale? Have you ever tried cooking a meal for 6 people? Cooking a meal for 6 people does not cost 6 times as much as cooking a meal for 1 person. Now, this is economies of scale in household production. So there's five reasons. Any more important ones?
Well, as households rise, the additional members won't necessarily be earning.
Yeah, that's the first one. Total income fixed.
No, not fixed. The additional members that come in may rise income, but not at the scalable rate, not multiplicatively.
Okay, well, it's related. Okay, any more reasons?
Bulk buying reduces the cost of buying, so you're only making as many trips to buy when you buy in bulk. So the cost of buying, not just the bulk buy, but the expenditure goes.
The purchase trips.
Purchase trips.
Yes, if you're a large household, maybe you make less trips to the supermarket, so you're spending less on petrol and so on. Anyway, those are the main reasons. Look, this is quite a useful example because this is the sort of thing you should be thinking about when you do your data analysis, you get your regression results, and you're asked, interpret the results. When you're asked to interpret results, you should be using economic concepts, such as economies of scale is an important one. Economies of scale comes up all the time. Let's be specific about that. Economies of scale means cooking for 4 costs less than 4 times cooking for 1. That's essentially what we mean by economies of scale. The reason for that is you're only using 1 hob to heat the food. You only use 1 fridge to keep the food in. You only use 1 washing up bowl afterwards. There are lots of reasons for that. So as I say, when you're interpreting things in econometrics, these are the sorts of things you should be thinking about. Any questions about the exercise generally? As I said, the main purpose of this seminar was to just introduce you to Stata. A lot of you have seen it already because you did the pre-sessional, or you may have seen it before that, but still, I'm sure it's been useful to get back into it. The other reason for this seminar was to sort out all the problems. You know, it's these workshops, we're calling them workshops. The workshops are going to go, they're bound to go more smoothly from week 2 onwards, precisely because we've addressed a lot of the problems that we've become aware of in this session. Any questions? What's the time?
20 to 11.
Okay, well, this session will always start at 9:30. It will usually carry on until at least 10:30, but it probably won't carry on until 11:30. It might last for an hour and a quarter, an hour and a half. That's the expectation. Before you go, I'll just give you the piece of paper with all these commands on.
You give them that and I'll get the QR code up.
Oh, QR code, but there are 3.
Okay.
I don't think we should worry about it this week, to be honest. I mean, you can if you want.
Okay, it's just
You can get the other sites. Oh no, wait, how do you do it? Through the timetable?
Yeah.
Okay, you do that.
But your time, what you?
You probably need my login.
No, I am logged in as you. So you come here and open.
Okay, you give this up.
Yeah, and you open. If you open your Outlook and go to your Outlook calendar.
Okay, I've got it. Yes, I've got it.
Yeah.
Yeah. Those of you who are online, I'm going to put this document online in the next hour or so. It's just a document making clear what we've just done in the last hour, the list of commands, and so on. Oh, well, that's good to hear that the online people could hear what we were doing. Okay, just another thing before you go, I'm going to try to tell you what the QR code is. We need to try this out as well. It's not important this week, but let's try it out. Oh. No, it's not working. I'm trying to get you a QR code, but I'm unable to get it. But in future workshops and lectures, we will give you a code which you, using your mobile phone, assuming you have one, using your iPhone, you can prove that you're present at the lecture or workshop. We'll be doing that from next week. Okay, that's the end of the workshop. Joel, have you given out the...
Yeah, I have, yeah.
See you on Monday in an online lecture.
Yeah, I guess we're all at the same thing. You know when the